Have you ever stared at a massive cloud dashboard and actually felt a physical knot form in your stomach? IT teams often call this ClickOps, the stressful process of setting up network servers by manually clicking through endless menus. The problem is, humans get tired. A single typo or a missed checkbox deep in the settings can crash an entire application. Clicking around is fine if you only need to set up one server, but imagine your company goes viral overnight. Suddenly, you need 100 new servers and 20 perfectly configured firewalls, and you need them right now. You simply cannot click fast enough to build all of that by hand. When you're trying to grow a business, these manual delays and typos pile up. Eventually, the team spends so much time fixing old mistakes that they can't build anything new, bringing the whole operation to a standstill. To solve this bottleneck, a company named HashiCorp created Terraform. It is the industry standard for a concept known as infrastructure as code. Think of Terraform as a universal remote control for the cloud. Instead of logging into a website and clicking buttons, you simply type out a plain text shopping list of the exact resources you need. By shifting from clicking buttons to writing a list, building a data center is no longer physical labor. Your entire cloud infrastructure becomes software, which means you can save it, share it, and reproduce it instantly. Building modern cloud environments is a lot like assembling a massive 10,000-piece Lego city. The old way to automate this was to use imperative instructions. That means giving the computer exhausting step-by-step commands. You'd have to say, find a red 2x4 block, pick it up, place it exactly 3 inches from the edge. Terraform uses a far easier method called declarative coding. Instead of giving step-by-step instructions, you just show the computer the final picture on the front of the Lego box and say, make it look like this. You define that final picture using HashiCorp Configuration Language, or HCL. It takes all those tedious manual steps and collapses them into one clean, readable block of text. The burden of figuring out how to build the infrastructure is lifted off your shoulders and handed directly to the software. Most companies today do not rely on just one cloud. They juggle resources across Amazon, Microsoft, and Google. Usually, each of those platforms requires you to learn an entirely different instruction manual. Terraform acts as a universal translator. It uses small add-ons called providers. You write your blueprint once, and the provider translates it into the specific language of whichever cloud platform you want to use. This bar chart compares Terraform against other tools, showing average setup time in blue and consistency in red. You can see Terraform builds environments faster, taking about 52 seconds to get everything running, and maintains a consistency score of 98.4% across different platforms. Because Terraform works across all these platforms, your company isn't locked into a single vendor. Engineers only need to learn one tool to deploy across all the major clouds. But this raises a scary question. If you run your deployment code twice, does the cloud accidentally build a second set of servers and double your monthly bill? Thankfully, no. Terraform has a built-in memory called the state file. It acts as a strict inventory list, recording exactly which Lego blocks are already sitting on the table. This enables a feature called Idempotency. When you tell Terraform to build, it checks the state file first. If it sees your server is already running, it safely skips that step, so you never end up with duplicates. Having your entire infrastructure written down as a text blueprint and a state file also gives your security team a huge advantage. They can scan your code for vulnerabilities long before any real servers are actually built. The state file separates Terraform from a basic automation script. It turns the tool into an intelligent, persistent manager that always knows exactly what your environment looks like. So, what does an engineer's actual day look like using this tool? It boils down to a predictable 4-step workflow. Step 1 is write. You draft out your declarative blueprint. Step 2 is init, or initialize. Terraform connects to the internet and automatically downloads the specific instruction manuals required for your chosen cloud provider. Step 3 is plan. Terraform generates a completely transparent preview of exactly what it intends to build, alter, or destroy. You get to see what will happen before you spend a single dollar, guaranteeing 0 surprises. And step 4 is apply. You approve the plan, press enter, and the cloud builds itself precisely to match your blueprint. This workflow replaces human guesswork with predictable automation, making the whole process of launching new resources feel much more routine. This changes how engineers work. Instead of spending the day clicking buttons to maintain servers, they can focus on designing how the entire system functions. By treating your infrastructure as code, your team can scale its operations up to thousands of servers without having to work any harder than you do today. If you want to see what this looks like in practice, look at the pinned comment below. Follow the link to the Terraform registry, look up the aws.instance resource, and see if you can identify which line of code defines the size of the server. If a collaborative, fast-moving DevOps culture is what your company wants to achieve, Terraform is the power tool required to actually build it.